All right, on this video, we're going to look at the second derivative test. The second derivative test is important to know about, although it's not something that you'll really use an awful lot. The reason is the first derivative test will usually do what you need it to. The second derivative test says that if the second derivative is continuous near C, if the first derivative is 0, let's look at what this says. If the first derivative is 0, and the second derivative is positive. So what that means is the second derivative is positive, so it's concave up. Then you're going to have a minimum at that point. And if the first derivative is 0 and the second derivative is negative, so that means it's concave down, then you'll get a local maximum at that point. So the second derivative test can help you find local maximum and minimum values, but it's not, in my opinion, it's not as useful as the first derivative test, because right here, if the second derivative is 0, then the second derivative test is inconclusive, and so it's not helpful in that case. Also, finding the second derivative, as we saw in this problem back here, example 203, finding the second derivative sometimes is a big pain compared to just finding the first derivative. So if you're looking for max and min values, it makes sense to just use the first derivative test. But the second derivative test, it's something you should at least be aware of. I want to do a couple of examples right here. Use the second derivative test to find a relative extrema of this thing. All right, so f prime of x is going to be 12x squared minus 6x. And if I set that equal to 0, that's going to give me, I can factor out 6x, and I'm left with 2x minus 1. So this gives me critical values of 0 and 1/2. So those are critical values. And what the second derivative test tells me is, if I take the second derivative, let's see, the second derivative of this is going to be 24x minus 6. If I take f double prime of 0, I get negative 6. So that tells me that it's concave down, which is shaped like a frown. So that means I have a relative max at x equals 0. Now if I do the other one, f double prime of 1/2, that gives me 24 times 1/2 minus 6. So that's 12 minus 6 is 6. That's positive, so that tells me that it's concave up. So that tells me we have a relative min at x equals 1/2. If we graph this, function 4x cubed minus 3x squared, then you can see, yeah, we do have what it says. A relative max here at 0 and a relative min over here at 1/2. So the second derivative test, it lets us figure that stuff out without having to draw out the chart. But in this case, it wasn't really that much trouble. But the second derivative test can be a bit of a pain. Let's look at one more example. What does the second derivative test tell us about the graphs of this and this? All right, well, for f of x, f prime is going to be 4 times x plus 3 cubed. So that's going to give me x equals 0, or no, x equals, I'm trying to I'm trying to be fast and making mistakes. So let's do this. Do this nice and slowly. So to find the critical numbers, we get x plus 3 cubed is 0 if I divide both sides by 4. So I get x equals -3. Now f double prime of x, if I come back up here and take the derivative of this, I get 12 times x plus 3 to the second power. If I do f double prime of -3, notice I get 0. So the second derivative test is inconclusive. Doesn't tell me whether I've got a max or a min because I got a 0 there for my second derivative. For this other graph, for g prime of x is going to be minus 25x to the fourth. That gives me a critical number of x equals 0. If I do the second derivative of this, that gives me negative 100x cubed. And so the second derivative evaluated at 0 is 0. So second derivative test is inconclusive here as well. So if you look at these graphs, if you were to graph these, x plus 3 to the fourth is going to look like this. It's going to be like a flattened parabola over here. So this one has a minimum, but the second derivative test is unable to detect it. And same thing over here, minus 5x to the fifth. This one's actually maybe a little more interesting. This one is shaped like this. It flattens out. Let me draw that a little better. Negative 5x to the fifth is going to be shaped like that, except it should be flatter than that. But this one, it actually has an inflection point there. It doesn't have a max or a min. So the second derivative test can fail. But it is a useful thing to know about. And that's all I want to say about the second derivative test.